Let's say you go to the store to pick up cleaning supplies. Perhaps you're going to clean your floors, and so you buy a bottle of concentrated cleaning solution. Now, the word concentrated tells us qualitatively that there's a lot of solute in our solution. And when I go home, I don't use it straight out of the container concentrated. Instead, I pour a capful in, whatever the directions say, and I add some water. So I dilute it. And when a solution is dilute, that means that I have less solute in that solution. So qualitatively, or in descriptive words, I can say concentrated and dilute. However, if I was working in a laboratory, or perhaps I was giving a proper dose of a liquid medication, qualitative words like concentrated and dilute are not sufficient. So we have concentration units that help us know the amount of solute that is in our solution. And that's what concentration is. Concentration is a description of the amount of solute that is in a given amount of solution. And when they're talking about the solution here, that means the solute and the solvent together. So there are several concentration units that are used. And in this course, we're going to look at two. In this video, we're going to look at percent concentration. And then in a future video, we're going to look at molarity. So let's start with percent concentration. As the name implies, percent is going to be a percentage. Now there's three different ways to write a percent concentration. But one of the things that is similar about all of them is they're going to be comparing weight or masses to volumes and volumes. Anytime in this one we have weights, we're going to use the unit of grams or G's. And we have volumes, we're going to use milliliters. So in percent concentration, it's helpful to remember those units. Now the three ways that we can represent it is we can have weight to volume comparison, volume to volume, and weight to weight. Now if I look at each equation, so if I start weight to volume, you'll notice that weight is in grams, so I have the grams of my solute divided by the volume is in milliliters, the milliliters of solution, and then it's a percent, so I times it by 100. Now notice here the solute is over the solution. Now volume to volume, as the name implies, means that I will be comparing the volume, which is in milliliters, to a volume which is in milliliters. And again, it's solute per solution. Remember, that's the definition. It's the amount of solute I have in a given amount of solution. This one also has times 100. And then finally, the weight to weight. So weight is in grams, so I compare the grams to the grams, solute over solution, and times 100. So let me erase all the markings, and I want you just to study this again. And notice that what they all have in common is they are all comparing the solute on the numerator to the solution on the denominator, and they all are times 100 because they're all percentages. So even though there's three equations, which seems kind of overwhelming, the difference has to do with what you're comparing. And so then that difference then is reflected in the units. Remembering that if we're comparing the weight, that will be in units of grams. And if something's comparing the volume, that's going to be in units of milliliters. So let's see how we would apply these equations into working problems and calculating concentration. So in this problem it says, an over-the-counter medication for upset stomach contains 525 milligrams of bismuth subsalicylate. So it has 524 milligrams of the solute, and it is contained in each 15 milliliter tablespoon of the solution. So we have 15 milliliters. So what is the weight? So that's going to be grams, on top is solute, per volume, which is going to be milliliters of solution, and then percent, so times 100. So I first look and I see, I have 525, it's milligrams. So in this problem, I would have to go think about converting milligrams to grams. There's 1,000 milligrams in 1 gram. We learned this in the beginning of the course. And so 525 divided by 1,000 is 0.525 grams. So then I could plug in, because I need grams, 0.525 grams divided by 15 milliliters of solution. I was given both of these numbers, times 100. So plugging in, I have 0.525 divided by 15 times 100, and I have that this would equal 3.5% weight, that should be a W, weight to volume, or sometimes I write weight to volume percent, either way, and this is of the bismuth subsalicylate. I don't think I can fit that writing there. So this is the concentration of the bismuth subsalate in the medication. So let's try this one. A 250 milliliter bottle of mouthwash contains 21 milliliters of ethanol. What is the volume to volume percent? So volume to volume means that milliliters, it's always solute on the top, divided by, it's another volume, milliliters of solution, because volume and the percent is always milliliters, times 100. So looking at this problem, ethanol is my solute, which would always be the smaller amount. So this is 21 milliliters of ethanol, and it's in a 250 milliliters of bottle, so that's how much solution I have, times 100. So plugging into my calculator, 21 divided by 250 times 100 is 8.4% volume to volume of the ethanol. So this mouthwash is just over 8% ethanol. So you can see it's pretty straightforward when they're asking you to calculate percent concentrations. You would be given the amount of the solute and the amount of the solution. The difference would be in whether you're dealing with weight, which would be in grams, or volume, which would be in milliliters. Now, sometimes the question doesn't ask us to calculate the concentration, but asks us to calculate another piece of information. So this question says how many milliliters of ethanol are contained in a 30 milliliter portion. We have to read this one carefully. So it says how many milliliters of ethanol are contained in a 30 milliliter portion. So this is our amount of our solution. And they tell us that the concentration is 8%. So notice this is different than the previous problems, because in the previous problems, they have been asking us to calculate the concentration. But instead, this time they're asking us to find the solute. Now there's two different ways to solve this problem. I'll solve it the algebraic way here, and then we can try to solve it also using the concentration as a conversion factor. So to solve algebraically, we would just plug it in. So I know that the percent volume to volume is going to equal the milliliters of solute divided by the milliliters of solution times 100. So I would plug it in, and I have 8% equals, I'll just put V for my volume, that's what I don't know, divided by 30 milliliters times 100. So I would multiply the 30, so I'd have 30 milliliters times the 8 equals V times 100. And then I could say V equals 30 times the 8 divided by 100. And so then V equals, doing the math, uh, 2.4 milliliters. So what I'm solving for, if you reread the problem, it says how many milliliters of ethanol are contained in a 30 milliliter portion of mouthwash that has 8% concentration, and there would be 2.4 milliliters of the ethanol. So this first way that I showed you, that's just plugging in and using algebra on this side. Now the second way you can do it is using concentration as a conversion factor. And as I do this more and more, I prefer this way, but sometimes it's initially hard to see. What you have to understand is what 8% means. And this is volume to volume. And what it means, a percent means out of 100. So 8% would tell me I have 8 milliliters in 100 milliliters. And it's 8 milliliters of my solute, which is my ethanol, and 100 milliliters of my solution. That is what the 8% means. Well, recall, anytime I can write one thing on top of another, then I can use that as a conversion factor, flipping it how I need it to cancel units. You never start the problem with the percentage. Instead, you'll start with the other information. So they tell me I have 30 milliliters of my solution, my mouthwash. And so this was given. And if I multiply it by the concentration, and I want the solution to be on the bottom so it will cancel, I could flip it to do the other. And this would be ethanol as my solute in this case. The milliliters of solution cancel. And I get 30 times 8 divided by 100. So then this answer also equals 2.4 milliliters. It equals, mathematically, it's the same thing. It just only really takes, in this example, one step right here. So that's why I like it. And so this is, the second way is using concentration as a conversion factor. Now, I don't advocate for one method over the other, although I do prefer the second method because it kind of shortens the process. But I just show you both so you can practice and try to figure out which one is best for you solving problems. So here's another one, and let's try it. You might go ahead and try to do it before I start doing one way or the other. And I'll do both ways again. So I read this problem. A saline solution used in IV drips contains a 0.92% weight to volume sodium chloride. So this right here is my concentration. And it says how many grams are contained in 250 milliliters of this solution. So this is the total amount of solution. So doing algebra first, I'll try that first. So this time I have weight to volume. So I know that the grams of solute, I know that the percent concentration, the percent is going to equal the grams of the solute divided by, because it's volume on the bottom, the milliliters of solution, see, weight to volume, times 100. That's the equation for percent weight to volume. So in algebra, I would just plug it in. So I'd say 0.92% equals, well, the gram, how many grams? That's the question. So I'm just going to put W because I don't know that for weight. And the milliliters of solution, which is 250 times 100. So I say I multiply the 250 over. I'm trying to solve for W, and that would be W times 100. And then I would divide the 100 over. So I get 250 milliliters times 0.92, that's 0.92, divided by 100. So 250 times 0.92 divided by 100 equals 23. So it's 23 grams of sodium chloride. So in a saline drip, if you had 250 milliliters of that solution, that would contain 23 grams of sodium chloride. Now I could set up the same problem so you can see using concentration as a conversion factor. So I know that it's 0.92% in its weight to volume. A percent tells me, this number tells me I have 0.92, its weight, grams in every 100 milliliters because it's weight to volume. So percentages, this number here tells me how much I have out of 100 because that's what percents are. So I start with what I was given, which was 250 milliliters, and I use the concentration as a conversion. I would put milliliters on the bottom and the 0.92 grams on the top. So then I get 250 times 0.92 divided by 100, and then my mass would equal the same answer, 23 grams of sodium chloride. So either way you decide to solve these problems, either using algebra or as a conversion factor, you can also use, there's many ways to solve, or you can use concentration to solve this many ways.